This video is to prove that there was a time before the Big Bang. The main things we are discussing here are the formation process of the Big Bang Singularity and the interactions between the energy and the space-time. We all know that the Big Bang was about 13.8 billion years ago, and yet the universe continues to expand at an accelerating rate. We cannot imagine how big the universe is and how much it expands more. The Big Bang was caused by a singularity that was created by a strong unified gravitational interaction. We don't know how much energy was there inside the Big Bang Singularity. We cannot guess how many billions of years it took to store this much energy in the Big Bang Singularity. Naturally, we can see the presence of a time for the formation of the Big Bang Singularity now itself. The universe is a great sanctuary of mysteries that we still do not understand. We still do not know how exactly the universe was originated. The origin of our universe is one of the most discussed topics in physics. Several theories have been put forward to explain the origin of the universe. Based on the evidence, the theory of Big Bang is widely accepted now, but we still do not know what was there before the Big Bang. Let us try to understand more about this period. For that, we can divide the universe into two periods. The Big Bang can be taken as a focal point. Let us call the universe before the Big Bang as the primordial universe, and the universe created after the Big Bang can be called as the present universe. To understand more about this, we need to know about the conditions before the formation of the Big Bang Singularity. It is important to understand the state of energy at that time. We need to understand what space-time was like and how space-time and energy were related. How space and time were related in that period is also important. Many say that there was no time before the Big Bang, but I don't believe in that concept. In this video, I would like to discuss more about the conditions of the energy, space, and time of that period that we still do not understand. And so let us see how this state of energy is combined and how the singularity that caused the Big Bang was formed. We all know that during the formation of this singularity, the Big Bang takes place at a certain point and the time starts there. Two problems that confuse us begins here. Here we see the first problem that arises to confuse us. What is the time? Where was it? What was the time at the gravitational singularity? Was it at zero value? Or was it a part of the energy liberated by the Big Bang? Was there time before that? Still, we don't know what it is. We are running with the time or it is running with us. The second is more complicated. Why did the Big Bang happen at that particular time? Couldn't it have happened a little bit earlier? Or couldn't it happen after accumulating some more energy into the singularity? The same question often comes to my mind when thinking about the star formation. Why do all the stars differ in size and mass? We explain it in many ways, but I have my own way to explain the reason for every phenomenon occurring in the universe. Let us start with the singularity. So what is a singularity? In general, many people try to view singularity as a mathematical model only. But we can say that singularity is possible because we already have the evidence of the Big Bang. There are some more misconceptions about the system of a singularity. One of the most important of these is that the value of time is zero in singularity. I have to admit that it is true to some extent. The second is that there was no space-time in the Big Bang singularity. This is because of the way we understand the universe. All these things are well described in my book, The Key to the Secrets of the Universe. Or you can watch our other videos, or you can visit our website. All the needful links are in the description box. We have already discussed how matter is accommodating in space-time in my other videos. Matter can never exist without the presence of space-time. Most importantly, the Big Bang singularity was not created in just a moment. The energy that encompasses the entire universe has to concentrate in one place over a process of billions of years. So it must be said that there was the time before the Big Bang also. Then how can we say that there was no time in the singularity? For that, we need to understand how energy and space-time are distributed in the universe. The building blocks of the universe are the space-time and matter. This picture will help us to understand more. We are now trying to understand the distribution of energy and space-time in a selected part of the system. From this, we can determine the size of the system and the amount of energy and space-time within it. The parallelogram in this picture is divided into two triangles, triangle CFD and triangle EDF. Here I call CDF as HIR and EDF as URO. Triangle URO represents the distribution of time of the total system. Similarly, triangle HIR is the distribution of space in that system.
These two triangles have a common side and I call it r. The maximum distance at which energy and space-time can interact is r. It is also the total distance that interact with the space and time within the space-time. We can see that the distribution of space and time inside the system are in opposite directions. We can see that the distribution of time increases with the distance from the center. Similarly, it can be seen that the distribution of space decreases as it moves away from the center. We can see that they are both increasing and decreasing in the same proportion. As the distance from R to O decreases, the strength of the distribution of time is decreasing. I wish to call this distance as Y. We can see that the decreasing strength of the distribution of time is moving closer to a zero value. Similarly, as the distance from R to I decreases, the strength of distribution of space is also decreases, and I wish to call this distance as M. So we can find a new equation based on this picture. M plus Y is equal to H. The sum of the distances from any point of R to I and O is H. Here space and time combined together become the only one dimension of space-time. If the rate of distribution of time decreases, the rate of distribution of space increases proportionally. That is, the energy is exerting its influence on the system is the same everywhere. So at each point of R, the effect of space and time will be different. That is, inside a system, the time and space are distributed step by step along with energy. A quanta of energy can have a certain amount of space-time of its own. Space and time will have been distributed in proportionally in that space-time. So if you add one quanta of energy to a system, it will add a proportional amount of space-time to the system. So we can clearly say that the time and space are quantized here. We can say that the system is also quantized because the energy is already quantized. Time and space are located within the quantized system. So let us look at the most center of the picture. There we see that the value of y, the distribution of time, is approaching to 0. Similarly, as the value of y increases, the value of m, the distribution of space, decreases to become 0 at the end. That system ends there. On the space-time beyond that, the system will have no influence. The same thing happens with R. Apply an equal amount of force to each point of the distance from F to D, and when it finally reaches D, everything is over. Imagine that you are walking in a street and you have 100 coins in your hand. If you throw a coin at each of your steps, you will not have a single coin left in your 100th step. The same thing is happening in this system. Energy is applying its strength equally to all parts of the system under its influence. Eventually, the interaction between energy and space-time is completely eliminated. Similar things are happening in a singularity. As it approaches to the center of the singularity, space distribution becomes more and the distribution of time becomes less. Finally, we can see that the value of time becomes 0. That is why we say that time ends at the singularity. To some extent, this is true. This is a flaw in our understanding of singularity. In all other contexts, we associate space-time with matter. But in terms of singularity, we are only looking at the matter. We must consider any object in the universe as an independent system. Now, whether it is an atom, a star, or a singularity, it is an independent system. All these have the same importance in the universe. A system of space-time and matter. Matter cannot exist without space-time and space-time cannot exist without matter. Both two are parts of the system. Although interrelated, space-time is never a part of the matter. Matter just exists in the space-time. Let us look at the structure of an atom to understand more about this. We know that the electrons orbit around the nucleus of an atom. We consider electrons to be among the fundamental particles called leptons. We can see that there is a lot of space between them. If we look inside the nucleus, we can see protons and neutrons. While they are connected to each other, there must be a tiny space between these particles. Protons and neutrons are made up of fundamental particles called quarks. When these quarks are bound together, some space remains between them also. So far, we have been able to understand up to this limit. That's why we call quarks and leptons as fundamental particles. If quarks and leptons were to be the real fundamental particles, they would not allow any space inside them. Only matter is possible there. Then the particle will be in the smallest possible volume that a unit of energy can acquire. Here, space-time is completely outside of matter. Although space-time and energy are correlated, they are two different systems. There is neither time nor space within the matter. The singularity is also almost in this state. A singularity is a state in which space within the matter is completely eliminated, leaving only matter alone. Matter shrinks to the smallest volume that it can achieve. Therefore, it can be said that there is no space-time in the singularity. But since the singularity is only a part of the system, then it must be said that singularity exists within the space-time. The operation of space-time depends on the distribution of its two fields. The distribution of time field increases as the distribution of space field decreases. In effect, the time to the center increases with increasing distance. So the total strength of the energy at the space-time R is S is equal to R into M plus Y, or S is equal to R into H. Since we consider space-time here as a sphere, we can write the same equation as S is equal to 4 by 3 pi r cube h. This is because r is equal to the radius of a sphere. Here we need to find the amount of space-time proportional to each quanta of energy. I have just presented a simple form of the equation to get the weight to it. We are still working on to find the better one. This image describing the structure of space-time is very important. We can describe the entire universe using this picture. Let us see how we can describe the famous equation of Einstein E is equal to mc squared using this same picture. Energy is described as the combination of two systems. Here M can be represented as matter and c square as the space-time. For each quanta of energy added to matter, a quantity of quantized space-time c square is added to the system. This equation explains the entire universe itself. So the ratio between matter and the space-time in the universe is m is to c square. This same picture is the key to the theory of everything we are looking for. With this picture, we can unify all the dimensions of energy. Now it can be understood that any form of energy cannot exist without containing space-time. Now we can see the formation of the Big Bang Singularity to prove there was a time before the Big Bang. Let us examine the possibility for the gathering of the primordial particles together to form the Big Bang Singularity. Here we are discussing the general idea of it. Some of my other videos I explained 3 different possibilities for the formation of the Big Bang Singularity. If you are interested, you can watch it. One possibility is that none of these primordial particles were distributed in the primordial universe in an exact proportion. There was a variation in the number of particles distributed in each region and distance between them. Therefore, a widespread imbalance was evident in the primordial universe. Due to this imbalance and the lack of a precious criterion for this distribution of these particles, there was a situation where the particles could interact. Things become much easier when gravity, the basic nature of energy, was added to stimulate it. Wherever they are able to interact, these particles are attracted to each other with the help of gravity. The fusion of the primordial particles based on the theory of relativity can explain in this way. Two primordial particles form a curvature in space-time at 2 different places and were combined together to create a slightly larger curvature. We can use this picture for more clarity. Picture the primary integration. This image represents the early structures which are created by the attraction of energy in the early universe. All the black regions of the image are clusters of different sized primordial particles that have coalesced at different rates in several phases. In this picture, we can see many black spheres of different sizes. We can interpret the formation of these spheres in 2 ways. First, we can say that many spheres have been formed in several places. Or it could be said that instead of having many spheres, there was only one sphere. That is, the primordial particles that were located in an unbalanced universe began to be concentrated in a certain part as the result of their gravitational pull. We can see this as the beginning of the gravitational singularity. I would like to explain things in the first way. Either way, we are finally coming to the answer to the Big Bang based gravitational singularity. If we adopt the first method, we can easily find answers to many questions. We can present things like drawing a picture on a very large canvas. Now let us see how the universe evolved into the Big Bang Singularity. Let us see what happens when these particles merge together. For example, suppose that 2 particles intersect, it is there eliminating the space-time between them. As it grows more and more, we see a situation where space-time disappears. Or we could say that it is a form that is located inside the space-time. Separate the space-time and create a singularity. After the Big Bang, it expands into the same space-time. Now we understand 2 things. How big was the universe before the Big Bang? How much space-time is thrown out there to create the Big Bang Singularity? Today our universe is regaining the space-time it had lost for the creation of the Big Bang Singularity. But this process is still going on for billions of years after the Big Bang. You can only imagine then how long it will take for the creation of the Big Bang Singularity. The fact that the universe is still expanding means that the previously lost space-time has not been recovered totally. Probably when it has absorbed enough space-time, the universe will stop growing itself. In the early days, the fusion took place very slowly. As the size of them increases, the gravity increases and the rate of this process increases. The particles groups were formed into many parts of the early universe with the help of gravity. They were attracted to one another and thereby converged on the avatar. There was a time before that. We can say that a new time was born with the Big Bang. With the Big Bang, the energy begins to grow again into the space-time. At singularity, the energy did not encompass the space-time. Space-time was out of the singularity there. A space-time will already created there. If we look at the history of the particle in this way, we can split the time into several stages. A time until a particle remains in that state. When it merges with another particle, they start together a new time. Now it has two distinct time scales for that particles. Its initial time and the new time which it have begun to join with the other particle. Thus it appears that at each step until it reaches the singularity, it begins a new time. But we can never say that it left its initial time. With the Big Bang, energy takes on a new form. Energy undergoes many changes and acquires all its fundamental qualities, which it did not yet acquire before, and comes to a new form. At the same time, we can say that it is the beginning of a new time. According to the special relativity theory, we need to look at the concept of space-time in detail. We can imagine two particles located in two different places in a space-time. Both of these particles distort space-time in their own way. Suppose these two particles combine together, then these two space-times combine together to become one space-time. The integration of space-time takes place along with the synthesis of energy particles. Just as energy is not destroyed during this process, the space-time is also not destroyed. Similarly, no more space-time or energy is created. The atom, which is compressed by the strong gravitational pull of a black hole, expels the space inside it. Even if an atom falls into a black hole, it will work according to this principle. The energy particles inside the atom became parts of the singularity, and the space is added to the space-time of the singularity. The space within an atom and the space-time distorted by its influence become part of the space-time of the singularity. This same principle can be seen in the formation of the Big Bang Singularity. Here the elementary particles combined together and grow into the Big Bang Singularity. At the same time, the space-time under their influence also join each other. The formation of the Big Bang Singularity was the result of joining the primordial particles one by one. Here the required energy is stored slowly. That must have been taken billions of years. So we can clearly say that there was a time before the Big Bang. Thank you for watching my video.